Hey everyone, this is Mayur. Welcome back to ML Works. In this video, we'll be discussing what is RAG and what are the things that you have to keep in mind while you are building a RAG system. So, RAG is nothing but a retrieval augmented generation where retrieval refers to the context that we are retrieving from vector database. Argument in a sense, user query plus the context that we got from vector DB. Generation refers to the LLM's response to the user query plus context. Okay, so that is what this keyword, each of those things mean. Okay, so what is also needs to be understand, it is nothing but an application pattern, a way a system is built, okay, for an LLM. So this is an application pattern for LLMs, and it uses information retrieval system, meaning you use vector DB to pull the information and use that for the large language model, which gives them the extra context, which will help them to answer the user query efficiently and also avoid hallucinations, which means avoiding completely out of the box response to the user query. So that's what the whole definition mean here. And next, let's look at this particular flow diagram where you have the structured and unstructured data, where you turn that into a chunks. That chunk is then passed to an embedding model, and that embedding model generates your vector of floating point numbers, and that is then stored in vector DB. Now then we have something called as retriever. Okay, retriever is nothing but whenever a user query comes in, okay, whenever a user query comes in, okay, that user query is turned into an embedding. That embedding is then uh, kind of what found done with the similarity with the vector DB's vectors. Okay, so it tries to do what are the similar documents which are similar to the user query. So retriever tries to find out using cosine similarity or any other distance metric and identifies the top k documents. Now that top k documents again re-ranked, and it will be along with that will be using some context that is generated from the document, and along with the user query that will be sent to the LLMs, and that LLM will generate the coherent response based on the user query and the context that is passed. So that is the whole flow. So let's understand once again, right, what it means. Chunking is nothing but structured unstructured data set into a text document into small chunks or small pieces. These small chunks can also be based on what, if you have some a paragraph, so the chunks can be sentences can be your chunks. Okay, now once the sentences are done, then you will be passing it to an embedding model, and then you will be getting a vectors of floating point numbers for each chunk. Okay, so that is, and since we are passing to the embedding model, it will, each vector will be nothing but a semantically induced vectors, where each word will have some relation with the neighboring words. Okay, so next is the vector DB, where we'll be storing our vectors that is generated in the previous step, and that will act as our data retrieval foundation for the data retrieval. Next step is retrieval, where you get the user query, and that query is turned into an embedding. That embedding is then used by the vector DB to identify top k documents, and those top k documents along with the user query is then used by the LLM, okay, along with the context, which is nothing but your document that you have pulled out, and then it is passed to the LLM to generate a coherent and informative response. So this is one part of your RAG. Okay. Now we have so many steps in between, right? So we have to understand if all those steps are working properly, the responses that we are getting from each step is those are valid or not. So we have to evaluate those steps. So then only it comes to the step where you have retrieval performance. Okay, where you have these metrics like precision, recall, and data ingestion. So the things that are getting pulled, all the chunks that are getting pulled, are they relevant or not to the user query? And again, so these two things refers to the same part. Are all the relevant documents are getting pulled, or all the irrelevant documents are getting pulled? So those things needs to be identified through a metric called as recall and precision. And also we have to understand the data ingestion, how we are getting, right? the semi-structured data, the complex document, how we are doing the chunking. That as well we have to understand. So that will help us in getting a better retrieval performance when we are retrieving from the vector database. Next is the response synthesis. So for consider, you pass in some fashion kind of a query, okay, and the LM end up giving a response which is quite offensive in terms of the kind of text it has generated. Okay, it could be based on racist, it could be racist, the response could be racist or sexually uh, misinformed or something like that, right? So that could be one of the response synthesis that we have to do from our end, okay, such that we don't end up what happened in Google use case, right? One of the thing which was recently happening, okay, where the response was quite racist, okay, when the Gemini model was introduced. So next is the tool use. Okay. So sometimes the response cannot be what perfect, and it cannot, the LLM cannot be what generating that perfect response. So what it can do is it can use tools which along with your RAG system, where it will, once the LLM is not able to find the answer, it will go to the tool and it will identify the some kind of search engine in the back end, and it will get the updated information from there. Okay. So that is one step you can do. And context accuracy. So again, the documents that are getting pulled from what the vector DB are those documents are even what are able to will be able to what help us in giving the perfect result or not. So that needs to be also understood, the context that we are getting. These three steps are the safeguarding, okay, tool use and context accuracy. Next thing is the response evaluation. That is the text that is getting generated. So in this case, what you can do is consider you are having a what you call you are using GPT 3.5. Okay, now it will generate certain responses to your query. Now you can evaluate those result that is coming from GPT 3.5 using GPT 4. Okay, that is one of the way to evaluate your GPT models itself. So this is the term called as LLM as evaluators, where one LLM evaluates the other LLM. Okay, this is one step. So another one is you can also use something called a synthetic data set that you can create and try to evaluate the responses for each of those particular queries or the data set whatever you have created, what is the response for that particular queries. So that is one way to evaluate your performance of your response that is getting from LLMs. Okay, so there are so many steps involved. So we have to go one by one in terms of performance if you are evaluating, right? So it the performance starts from here itself, the way you do the chunking and the way the retriever works and the way the LLM is providing the response based on the user query plus the document that is getting pulled from the vector database. So these are the bunch of things that you have to keep in mind while you are building a RAG system. So with that, I'll be concluding this video. Thank you so much.